In this video, I'd like to talk about the math question of the day for Friday, June 30th, 2023. And with this problem, we need to find the sum of the first 50 terms in this geometric series. And remember that a geometric series, we are adding up a set amount of terms, and each term going from one to the next, we multiply by some common ratio. So a topic like this is generally seen in a pre-calculus class, though sometimes you might see it in a more advanced Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And we need to add up 50 of these terms, which you can imagine will be very difficult to do by hand. But the key idea, remember, with a geometric series is that from one term to the next, we are multiplying by some common ratio, which we can say is r. We're multiplying by r. And since we're starting at 1 and going to 10/11ths, it's fairly clear that our common ratio is 10/11. Going from one term to the next, we're just multiplying by 10/11ths. And you can see that if we take 10/11ths and multiply it by itself, 10 times 10 is 100, 11 times 11 is 121. Now, if it wasn't as straightforward as this, what you can always do to find r is take one term and divide it by the one before it. If we take 100 over 121 and divide it by 10/11, we can change this to multiplication. 121 on the bottom, 100 in our numerator, multiplied by 11/10. We flip this and change it to multiplication. And we can cancel across. 10 goes into 110, so this simplifies to 10, this simplifies to 1. 11 goes into 121 and 11. We can divide them each by 11. That becomes a 1, this becomes 11. And we get 10/11ths, and this is our common ratio. So that's a more straightforward way to always be able to find it if it's not clear by just looking at it. And we'll need to use this to add up these first 50 terms. And I should mention there is a formula that if you know it, you can take your starting number and your common ratio and the number of terms you're adding and plug them into the formula, and it will tell you the sum of however many terms you're adding up. However, it's often difficult to remember formulas like that. And honestly, it's not a formula that I usually remember. So what I do remember, though, is how to derive it. And the way to derive it, we're going to say that a, that's our starting term or starting value. R is our common ratio. And we can say we're adding in terms. So this is the number of terms. So we will start with our a value, our starting value. Let me use a different color for this. And our next term we find by just multiplying by r. So this would be a times r to the first. Then we multiply by r again to get r squared and so on. And let's say we're adding up n terms. Now we have to be careful since this is our first term and this is our second term and so on. But notice that the exponent is always one less than the number of terms. So our last term here would be a times by r to the n minus 1 power. This will be the nth term here. So we have this geometric series. We can call this sum s. And the way to find the formula is that we will take s and just multiply it by that common ratio. So we can write r times by s, and we'll multiply each of these terms by r now. We're essentially just distributing. We get AR plus AR squared plus AR cubed and so on, all the way up to A times by R to the nth power now. And we'll take our original sum and subtract this new sum where we multiplied by R, so that on the right-hand side here, we're now subtracting this bottom pink series from the green one. And we start with a, and notice we don't have an a here, so that doesn't cancel out. We have a r to the first, and we're subtracting a r to the first here, so these will cancel. Ar squared minus ar squared, those cancel. And basically they all cancel. We would also have, I should write it in here, a times r to the n minus 1 plus this last term. So these would cancel as well, but we still have this term and we're subtracting it. So we have a times by r to the n. So we have an equation now that's greatly simplified for our sum, and we just need to solve this for s. So let's start by factoring s out. We get 1 minus r here. We can also factor an a out. A multiplied by 1 minus r to the nth power. And to find s, we just divide by 1 minus r, so we get a multiplied by 1 minus r to the n, all divided by 1 minus r. So we have our formula now, which we can always derive if we understand these basic principles. And we know that our starting value, if we go back up to the top, our starting value, a, is 1, our common ratio is 10/11, and the number of terms n is 50. So let's use that information. We can plug all of that into our formula now. We have a is 1, r is 10/11, and n is 50. So we have that s is 1 multiplied by 1 minus 10/11 to the 50th power, and we're dividing by 1 minus r, which is 10/11, and we could write this 1 here as 11/11, so we can actually subtract here. So we just get 1/11 in our denominator, and up top we are multiplying by 1, so we just have 1 minus 10/11 to the 50th power, and we're dividing by 1/11. So we can change this to multiplication and flip this fraction over. So we have 11 multiplied by 1 minus 10/11 to the 50th power. Now, this right here is technically our answer, but if we want a decimal value, we will have to figure out how to multiply this out. And if we do it by hand, that is quite complicated to do and very tedious, but we can just use a calculator at this point. So if we plug this into a calculator, what we get is that our sum here for the first 50 terms of that geometric series is 10.906 and so on. At some point, the calculator rounds this, so let's just round it to the hundredths place. We can call this 10.91. So this right here is our approximate answer.